Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. We saw that in a previous video that we could solve first-order linear differential equations of the form dy by dx plus p of x multiplied by y is equal to q of x, where p of x and q of x are either constants or functions of x, using an integrating factor such that the general solution of the differential equation is given by the formula e to the power of the integral of px dx multiplied by y is equal to the integral of e to the power of the integral of px dx multiplied by qx dx plus a constant of integration c. In the formula, the integrating factor is given by e to the power of the integral of px dx. For more information about integrating factors, check out this video, and I've included a link to it in the description. Armed with this information, let's see if we can solve this linear first-order differential equation using an integrating factor. So we have dy by dx plus 3x squared multiplied by y is equal to 6x squared. To begin, let's identify the functions p of x and q of x. So in this example, p of x is equal to 3x squared and q of x is equal to 6x squared. The integrating factor is e to the power of the integral of px dx. So in this instance, the integrating factor is e to the power of the integral of 3x squared dx. So evaluating the integral 3x squared dx, using the power rule, we have 3x cubed divided by 3, and this equates to x cubed. And so our integrating factor evaluates to e to the power of x cubed. So now let's plug all this information into the general solution of the differential equation shown here. So we have the integrating factor, which is e to the power of x cubed multiplied by y is equal to the integral of the integrating factor e to the power of x cubed multiplied by qx, which is 6x squared dx. So to find our solution, we need to evaluate this integral. So the integral of e to the power of x cubed multiplied by 6x squared dx. And to do this, we'll use a substitution. So we'll let u equal x cubed. If we differentiate with respect to x, we have du by dx is equal to 3x squared. It follows, therefore, that du divided by 3 is equal to x squared dx. And now if we substitute u for x cubed and du by 3 for x squared dx, in this integral here, we have 2 multiplied by the integral of e to the power u du. And this integral evaluates to 2 multiplied by e to the power of u plus a constant of integration. And substituting back in for u, which is equal to x cubed, we get 2 multiplied by e to the power of x cubed plus a constant of integration. So now we've evaluated this integral here. So therefore, we have e to the power of x cubed multiplied by y is equal to 2 multiplied by e to the power of x cubed plus a constant of integration c. Dividing through by e to the power of x cubed gives us y equals 2 plus c multiplied by e to the power of minus x cubed, which is the general solution to our differential equation.